Here we're going to do some practice at balancing some symbol equations. Okay, so it's all about practice. The first thing to know is it's all based on this principle called the conservation of mass. So this is the idea that during a reaction, okay, whatever you have at the start in some form has got to be there at the end. You can't destroy atoms and you can't make brand new ones. Okay, so if you have two types of atom at the start, you need those two types at the end. Let's do an example with magnesium to start us off. So if we react magnesium with oxygen, we form magnesium oxide. Okay, now if this is the reaction, okay, whatever we have on this side of the reaction needs to be exactly the same as on that side of the reaction. So this side is called the reactants, and this side is called the products. So what I always do, I always draw a big line down the middle, and so I'm really clear that whatever's this side is the same as this side. So let's start off. I've got one magnesium atom, and I have one oxygen atom. Oh, sorry, I've got two oxygen atoms there. On this side, I've got one magnesium atom, and I have got one oxygen atom. Now, at the moment, my magnesiums match, but my oxygens don't. Okay, so what I can do is if I add a big number at the front, I can change the number of atoms there. And the way the big numbers work is it gives times the whole compound by that number. Okay, so whatever number I put at the front, I have then that many lots of all magnesium oxide. So my magnesiums match, but to turn one oxygen into two, I need to multiply this by 2. This on this side, I need to times that by 2. So that would give me a big number 2 there. This would multiply all of this by 2. So yes, I would get 2 oxygens, but I would also get 2 magnesiums. Now my oxygens match, my magnesiums don't. So the only way I could get this side balanced now is if I times this by 2, big number 2 there, and now my formula is balanced because I've got 2 magnesiums on this side, 2 magnesiums on this side. I've got 2 oxygens on this side and 2 oxygens on that side as well. So this is balanced. Let's do some more for some practice. So let's do a reaction where we have hydrogen and we add it to nitrogen and we form ammonia. Okay, pause it now, have a go yourself, and then you can see if you got it right. Now the first thing I would always do is line down the middle where the reaction is, so I know I don't get confused, and count the number of atoms I've got this side. So I've got 2 hydrogens, and I have got 2 nitrogens on this side. On this side I've got 3 hydrogens, and I have got 1 nitrogen. Okay, now the first thing I would do is try and get the nitrogens to match. So to do that, I need to times this side by 2. So I put big number 2 to multiply all of this by 2. I would have 2 nitrogens, but it would also double the number of hydrogens I have to 6. So whilst my nitrogens now match, my hydrogens don't. So to turn this side into 6, I would have to times it by 3. So therefore, I would put a big 3 there. So 3 hydrogens, add 1 nitrogen, make 2 lots of ammonia. I've got the same number of hydrogens on this side as I do on this side, and I've got the same number of nitrogens on this side as on that side. So that would be correct. I'll give you one more quite difficult one for you to try. Give it a go first and then have a look at the answer. So let's try methane, add oxygen, so we're doing a combustion, creates carbon dioxide and water. So pause it now and have a go to try and balance that. Let's see what's on each side. So on this side, I've got 1 carbon, I've got 4 hydrogen, and I've got 2 oxygen. On this side, I've got 1 carbon, I have got 2 hydrogen, and I've got 3 oxygen. The reason I've got 3 oxygen is because I've got 2 there and only 1 there. Now, you may be at first not sure which one to start with, the hydrogen or the oxygen, but in this case, I suggest always starting with the hydrogen because you can leave this one here till the end. Okay, I'll explain a bit more in class. So, any numbers could go in the front, but first of all, I'm going to try and sort the hydrogens out. Therefore, I need to times that side by 2. So if I put a big 2 here, times all that by 2 to give me 4 hydrogen, will also give me 4 oxygen. Now, the carbons are matched, hydrogens are matched, oxygens aren't. So I need to double this side. Therefore, a big number 2 there. And that is the final one, balanced. Thanks for watching.